Greetings and welcome to another video lecture. In this one, we are going to go over, line by line, a simple Java program and compare it to how Python works. It's going to be a little bit of a long one, lots of talk. Sometimes we just got to do these. I do strongly encourage you this week to just open up Java or open up Visual Studio Code and write some just junk Java code. Start trying to get a feel for the language and how it is written. Now, before I start digging into the meat of this, one thing that I need to cover, because I forgot to cover it in the original setup video. You need to have the extension pack for Java from Microsoft. You need to have this installed. This is going to give you, make the quality of life a lot better for trying to do Java programming in Visual Studio Code. It is technically possible to do it without this extension pack. Trust me, you will want this extension pack. So you can get this installed before you start trying to run any Java code. All right, so let's start going over this line by line. Line 1, import java.util.scanner. Just like Python, Java is divided up into libraries because there are way more libraries available than you will ever need in any one given program. So you only import in the functionality that you need. Java.util.scanner is going to be a fairly common one. You're going to have that in practically all of your projects for this class because this is how you get input from the console. Import statements, like in Python, need to be the first series of statements that you have in your project. Now, for a major structural difference, in Python, you can just have loose code. You don't have to have any functions. You can just start writing code, and the Python script will run just fine. Java operates at a different level. Java is partially compiled, and then that partially compiled code is then what the Java machine runs to actually execute the program. To this extent, every single Java program must be contained within a class. And this class name must, absolutely must, match the file name. This is a significant difference from Python. Python did not require you to have a class or functions and absolutely did not care what the file name was. Java does. So if my primary class is called main, then my file name is going to be main.java. If I have a class called if I have a file called renderscreen.java, then my class had better be called renderscreen. And the capitalization must match. I have public class capital M main, and so therefore my file must be capital M main.java. I am stressing this so much because it is a very significant difference between Python and Java, and your program will not run if you have your file name and your class name not matching. So this is a very important aspect of Java programming. Another significant difference is you will see curly braces a lot more frequently in Java programs than you will in Python, in addition to almost every line ending in semicolons, like the if statement doesn't, and lines that are just curly brackets don't, generally. But practically every other line ends in a semicolon. Again, this is a major structural difference. Python used indentation to determine what belonged to what. So if you have an if statement in Python, you indent the code. to indicate that it belongs to that if statement. Java doesn't care. I can take this if statement here and completely unindent it. It's all the way to the left edge now. Java does not care, because Java uses the curly braces to determine what belongs to what. So these curly braces define that this line of code belongs to this if statement. And it also determines where lines end by the semicolon. I can, if I wanted, put this entirely on one line. This is valid syntax for Java. This would obviously not work in Python. You would get compile errors. Your Python code would not run. Java does not care. I could have practically this entire program on a single line of text. Don't do this, obviously. You still want to follow good coding practice, which is something that belongs to an if statement should be indented. So I've got the public class, indent. Public static void main, which is a function, indent. If statement, indent. Else, indent. Another if statement, yet another indent. These are not required for functionality, but they still make for more easily read code. If you come to your instructor for assistance and your code does not follow this basic kind of structure, where if statements are indented, classes are indented, functions are indented, good spacing, etc., one of the first things you'll be asked to do is fix your code formatting. Because it could be in the process of fixing your code formatting, you'll answer the question of why won't my code run? But the important part, for the getting back to the structure, public class main does not have to be called main, but it is tradition for your entry point class to be called main. Not required, just tradition. And then to indicate everything that belongs to this class, you will have an open curly brace and then a closing curly brace. All of your code must, absolutely must, be contained within this curly brace. Until we get to classes and we start talking about multiple class files and structures and things like that, just remember, all of your code must be inside of this curly brace. The only thing that can be outside of this for now is your import statement. That is it. Everything else must be contained within this initial set of curly brackets that indicate that it belongs to the class main. Ignore the run debug run main debug main. That's interjected by the extension. Next up, we have this function, public static void main string square bracket args. And again, a curly bracket, which I prefer to have on a separate line like that. It's one of those things that programmers like to have long-winded arguments over online. The important part here is this is your entry point. Public static void main string args. Every program is going to have one function like this. I said this is your entry point. When you specify that a class is your starting class for a Java program, you had better have a public static void main function in that class. We will go over this in more detail in a different lecture. But for now, just accept that this has to be here. And again, to indicate what belongs to this function, we have a curly brace. As we get into more complicated Java, not all of your code will be contained within this curly brace. But for now, all of your code must be contained inside of this curly brace. This is, again, very important. If you try to declare a variable outside of this, Java will let you. It is syntactically legal to declare a variable outside of your static void main. This is fine, expected even, once we get to classes. But you will not be able to use this variable inside your function, your static void main, for reasons that we will talk about later. But if I attempt to assign x a value, you will notice that I get a red squiggle of doom indicating that this is illegal, despite the fact that I very clearly have x defined up here. Again, this will be discussed in a future lecture. Just accept for the moment that as we're getting used to Java, all of our code must be contained within the curly brackets that define your main function. We will talk about the string brackets args later, but basically this is an array. Think of it as a list, kind of, sort of, in Python, of the command line arguments that were passed into this program when you started it. Variable declaration in Python. Java, I mean. In Java, you have what is called a strongly typed language. Python is loosely typed. You declare a variable, you assign a value to it, and now that variable is that data type. If I say in Python x equals 5, well, x is now an integer. If I say y equals 2.5, y is now a float. Java is not like that. It is strongly typed. When you define a variable, you must know what data type it is. So if principal is going to hold integer values, I must declare it as an int. If rate is going to be able to take decimal numbers, floating point numbers, I have to declare it as a float. Raw input, if I know I'm going to be assigning strings to this, it must be declared as a string. Notice the capital S. We'll get to why that's important for strings when we talk about strings, but just know that string is not a basic data type. It is something more complicated, and that is why it has a capital S instead of the lowercase letters that the basic data types have. Just like Python, I can assign initial values to it. And again, remember, every executable line of code must end with a semicolon. That is how Java knows you are done with this line. So I have declared an integer, a float, and a string. Assigned the integer and float to the initial value of 0, and the string to the initial value of blank string. Quick note about the yellow squiggles. These are warnings. These are not errors. So the compiler is warning me, or the IDE, I should say, is warning me that, hey, you assigned this value, but you never used this value, which is fine. That's intended. It's an initial value. This is how I code, and I would recommend that you always initialize declared variables to a default value. Next up, we have this odd little thing. Again, ignore the warning on this. We'll talk about this specific warning later. But I have capital S scanner, a variable or an identifier equals new scanner system.in. This is a little bit much to get into for this video, but in basic, what this is doing is scanner is a class. Again, Java is what's called an object-oriented language. Practically everything in Java with the exception of the basic data types like int, floats, and strings, are classes or objects. So in the scanner library, there is a, or I should say in the util library, there is a scanner class. And that scanner class has been written and defined for reading in information from system.in, which is the console for whatever system you happen to be on. And so I'm saying I want an instance of scanner called keyboard reader, and then to actually create that, I need this new scanner thing. Again, we will talk more about what exactly this means once we move on to classes after we've done a review on the basics. Of course, every program needs to have a way of displaying information to the console. In Java's case, it is system.out.print or println. Notice I have both versions. I have print down here, I've got println, I've got a few more prints around here. Oh, nope, just the one print. This displays input out to the console. Println automatically moves things down to the next line. Print does not, and we'll see both of these in action here in a moment. And much like the print function in Python, we just simply pass in a string for what we want to print out. Again, ignore the grayed out X. That's not part of the code that you type. That is something that the extension automatically puts in. And then here we have an example of how do we get input. Well, I do raw input equals keyboard reader.nextLine. Very similar to Python's method of getting input from the user. And just like Python, this is going to give me a string. So if I mouse over next line, you can see from the display here that string is the return type. And much like Python, if I want to do math with a string, well, I can't. I have to convert that string to a number. In the case of Java, I use integer, capital I integer, not int, dot parseInt, and then I pass in the string that I want to parse. Like Python, this can throw an exception if you are given invalid input here. Assuming that I get valid input, I then have an if statement. Again, the if statements are structured a little bit differently. For Java, the if statement is going to be enclosed in a set of parentheses. So I have if, open parentheses, the thing that I am checking to see if it's true or false, and then close parentheses. An if statement is one of the few lines in Java that does not have a semicolon. Notice there is no semicolon here. It will cause problems if you put one here. Don't do it. And then, as I mentioned earlier, I define what belongs to this if statement by putting in the curly brackets. So in this particular case, I am checking, is principal less than or equal to 0? If it is, I am going to print out an error. Principal must be greater than 0. Else, I'm going to continue, and again, I use the curly bracket to define what belongs to this else statement. The logical progression here is the same as it is in Python. You have if, you have else if, and you have else. So in this particular case, I'm saying if this is true, do this. else do all of this. So if principal is a valid value, another system.out, another raw input with reading the next line. This time I am parsing a float because this could be a floating point number. Actually, it should better be a floating point number. And again, a little bit of sanity check. If rate is less than or equal to 0, set of curly brackets to define what belongs to it. Again, if it's an error, I just simply print out error, rate must be greater than 0. Else, so if rate is greater than 0, then I do my math. Again, math equations work exactly the same in Java as they do in Python. I am multiplying these two together, so I use the asterisk symbol, and then I assign it to a new variable. And then I print out my results. Now notice for printing out the results, I am using concatenation. I have string plus variable plus string. There are ways of doing the string formatting thing in Java like you can do in Python, but it is more complicated, and we will deal with that when we talk about strings in Java. And then finally, we close the keyboard reader just because it's a good idea to do so. The program you will actually be yelled at here with a warning if you do not close the keyboard reader. We have our closing curly bracket that closes out the static void main, and then we have our curly bracket that closes out our class. Does this work? I don't know. Couple of different ways that we can run programs. Oops, I just realized I'm still running for some reason. Probably the easiest way is you just have it right here in the text, the ability to debug. So I'm just going to click on debug, and off it goes. It's running. Here we go. What is the principle? Whole dollars only. Notice that because I used print line, my inputs automatically neck down on the next line. And here, because I used print, my input is on the same line. There we go. And to show that the error handling works, now something happened here. I don't know if you can hear it through the microphone. I'm typing, but nothing's happening. What's going on? Well, my biggest enemy on this, F5 doesn't work. The way the extension works to be able to get input from the console, from the terminal, is you cannot run this through the default start debugging through the run menu, which is what F5 is bound to. You either have to right-click on the Java file and select Run or Debug Java, or you have to click on one of these options up here. You cannot use F5. I can promise you, you will see me try to use F5 more than once throughout the semester. Okay, so I can try to put in a negative principal, and boom, error. Principal must be greater than 0. Try it again. This time put in a valid principal. And try to give it a negative rate. Rate must be greater than 0. And there we go. We can see the logic in action. As you can hopefully see from this simple little program, the logic really hasn't changed. If we wipe away all the syntactical differences, this is a very basic, simple program that you should have no problem writing in Python off the top of your head. I have declared 3 variables. Ignore this one because there's not really any equivalent in Python. But I've declared 3 variables. I am displaying information to the user. I am getting information from the user. I am casting that information into the correct data type. I am performing some Boolean logic, determining which branch of execution do I need to take. If the output's error, to display an error. If the input's good, continue on with the program. Again, display, get input, cast input, validate, perform actions as necessary, display to the user, program done. The syntax is what's different, not the logic. The logic of declare variables, initialize what needs to be initialized, display information to the user, get information from the user, validate information from the user, perform operation, all of that's the same. The logic is the same. That's kind of, for me at least, that's one of the really awesome parts of programming. Once you learn one language, you are generally speaking only learning the syntax of a new language. You're not having to start over from scratch. And that's why we're going to move quite a bit faster through the basic syntax stuff in Java, because you already know Python. You've already gone through the Python class. You already know how to program. And so we can speed through that part, basically just review this, and then get to the more interesting parts of Python, which is all of this class nonsense. Because now that we're dealing with classes and objects and effectively being able to define our own data types, we can start writing a lot more interesting programs. I will do it for this video. A just quick reminder, make sure as far as your extensions go, you need to have the Java extension for the Oracle Corporation, and you need to have the extension pack for Java from the Microsoft Corporation. You need to have both of these extensions to be able to run code. When running your code, if you do not care about getting input from the user, you can just hit F5. You don't need to worry about going through here. However, if you need input from the user, if you need to get input from the console, when you run your program, you either need to use the run or debug here, or you need to right-click on your file and select run or debug from here. Do not hit F5 or go to run, start debugging if you need to use the console. That'll do it for this video. Happy coding. Catch you on the next one.